So the normal formula due to a point charge you already know. That is, see, electric field. What is electric field? First of all, you should know for electric field intensity. One thing that you should know is the concept of electric. Electric field is the space around a charge where electrical properties can be experienced. You bring up a test charge near this space and you are going to experience some electrical properties. This charge doesn't know that it is exerting force. It is just having its electric field. As soon as this test charge is stepping into this electric field, what is happening? Electrical force is being generated. So this is what is the concept of electric field, and you have the basic simple formula of electric field as force on this test charge divided by the charge. Using this, you have a good formula that you write as E is kq by r square. Now class, this is from your basic portion that we have done. But when we're talking about this electric field intensity due to a point charge, vector form is important. Because see, in one of the previous years, I showed you in the last class also, and we discussed it, that the questions have come from vector form. So there are chances that the questions can come from the vector form also, from electric field also. If they have come from the force, then electric field's vector form is also important. So nothing different. What we have studied already in the Coulomb's laws, vector form is the same. When you have kq by, now if I take the unit vector, that is r cap, it will be divided by r square. This is when this is the unit vector. And when I take the vector as it is, the vector r, the position vector r as it is, this will be divided by r cube. This is the position vector. So this is the difference. Now, if you have the options, like I'll show you the question that we discussed in the last class, this one. So this has come, all the options were there. So see, instead of the vector, again, one thing, it can mention you the symbol in bold. In bold, it can be given. This can be written like this. Electric field is kq, like this. R is in bold by r cube. This is the same thing. It is also the position vector. Position vector. Now, class, when we are talking about this electric field intensity, this formula E is kqr vector divided by r cube. So two things you have to remember for positive and negative charges. Once you have the positive charge, and on the other side you have the negative charge minus q. So for the positive charge, electric field, this is something different that we didn't discuss here, so pay attention. Electric field for a positive charge, if you see the charge is positive, charge is positive means electric field will be in the electric field in same direction. Same direction of what? Of position vector. We are not talking about the force and electric field. See, what did we discuss till now before this NEET part? We discussed that the electric force is in the same direction for a positive charge. And for a negative charge, we reverse the direction. But right now, we are talking about the electric field and the position vector. Okay? And it will be away from charge. Plus, it will be away from the charge. Like this. This means, see, suppose I take up a charge. This is the charge, point charge plus q. At this point P, I am calculating the electric field. So see, this is the separation. Let's say this is R. So electric field's direction will be away from the charge and in the same direction as that of the radius. So charge will move from this to our P point. We are bringing up the charge to the P point. So this is the direction of position vector. So this is the direction of the electric field. This is what you should know. And you will just reverse the things for the negative charge. If it is a negative charge, so electric field is in the opposite direction. Opposite direction of r vector plus it will be towards the charge. This is important. For the negative charge, many students don't know this, that this is towards the charge. See, individually, you know these properties, but see, when it comes cumulatively, what happens? It combines the concept of the direction of field line with the concept of the direction of electric field with respect to the position vector. So let's say this is the charge, this is minus q, and this is point P. So this is separated again by R, right? This is separated by R and R will be like this only. The negative charge will go towards the P point. So electric field will be towards the charge and in the opposite direction. So automatically you'll see this will be the direction of the electric field. Is that clear to both of you?
Yes, ma'am.
Jesleen, you understanding? Okay. All right then. If this is clear, first write it down. Please write it. Ibrahim, you have also written?
Yes.
Okay. So see, as I was telling you, see, I checked the questions again of the previous years. Dipole moment only comes along with electric field. Usually you have very, very less questions where electric field questions are separately asked in the NEET, if you see the recent questions. So we'll talk about electric dipole now. See, this is one thing is very clear. It's a system of two equal and opposite charges. This is what is meant by a dipole, and charges are at a very small separation to each other. The formula of dipole moment is very simple. That is, take the charge, multiply by the separation. Now here you can take the separation anything, take it as L or anything. You just have to give your final answer. You don't have to show your conventional NCERT's 2A. So you can write here as L also. L means the separation between the two charges. Separation between the two charges. That is what we write as 2A, because in your board exams you have to write it as 2A because it's given in the NCERT in that manner, and this is how it is included in your syllabus. But in NEET you have to give your final answers, and Q into L is sufficient till the time you know that L is the separation between both the charges, and it's a vector, and its direction, tell me class.
Negative to positive, yeah.
Negative to positive. Negative to positive. Now class, this is what we have already discussed, and we have discussed it multiple times. You all have done it also. See what kind of questions can be difficult, okay, or what are the modifications that can come. See, if you have a molecule, let's say HCl, there's a molecule, hydrogen plus is present, and you have chloride. So chloride is bigger than your hydrogen in size. So when you're calculating the net dipole moment here, so see, from the negative charge to the positive charge that we've studied, and the net in such a case, when you have the equal magnitude also, this will be neutral because there will be one direction. Whatever, let's say this is having some charge plus delta, this is having charge minus delta. So that will cancel off. But what if I change the arrangement of some molecules? Because it's a vector. See, in your CBSE syllabus, in your board exams, simple molecules will come like this. But in the NEET exam, it can modify it. How? If I change the arrangement of some molecules, let's say I have taken a charge Q. Let's say I have taken a charge, this is plus Q. Okay. Now Q, or not, let me take it as Q to the power 2 minus. Q2 minus, do you understand? Your chemistry part means one Q is bonded with some other one Q, the power that we write, like phosphorus, we write 3 minus, 4 minus, like that. Fe2 plus, Fe3 plus, this is what I've written, the charge. And I now take two hydrogen atoms, H plus, and here I take one more H plus. Now look, what is, I have changed the arrangement. Still, this is a dipole present. If I take, if this is Q2 minus, it means the minus 2Q can be written as 1 can have minus Q. There are two minus Qs, right? That is what I have written. So Q to the power minus 2, or if I write 2, this is also correct. Now class, see, this is separated to this hydrogen. This is separated to this hydrogen. So here also you are getting one dipole, and here also you are getting one dipole. This is acting as your plus Q, and this is your minus Q. So one with this, one with this, right? That is, this is a pair of dipole here. One here you have, one set here you have. But problem is that here the arrangement has been changed. Okay, we have the direction as negative to positive. So from negative to positive, let's say this is P1. And from negative to positive, let's say this is P2. So your final answer that you will write will not be P1 and P2, or what is the answer? Because it's a vector. So you will consider properly its direction as this will be the net dipole. So let's say if this is theta, this will also be theta by symmetry. So your net dipole moment will be 2p cos theta, right? This is what is your dipole moment. So if you change this symmetry, what we have studied, that was just for a simple linear molecule. I'll tell you this also how you have to solve. Let us do a question based on this. Or do one thing. First you write it, then I'll discuss a question. Just write down this part. Is this clear? Why have we written this as P net? Got it? And what about Ibrahim? You've understood?
Mm. Yes, ma'am.
Okay. Okay, write it. If you want to ask anything, you can. We'll discuss a question based on this one. Okay, class. Can I continue now? Ibrahim, you've written?
Yes, ma'am.
Okay. See, there is a question. You have to find the dipole moment. So how is the arrangement given? This is how you have the arrangement. One charge is there, minus 7q. And you have here a charge, minus 4q. And here you have a charge, minus 3q. And what all is there? The separation is given as a, and this is also the separation that is given as a. That's all that you have. Now see, in this question, we have to find out from 7q, we have to make up our dipoles. So what all possibilities are present? How should we make this 7q? We have to split it like the previous question. For minus 4q, what is essential? Oh, sorry, this is plus. For plus 4q, what is essential? Which charge do you require to make this a dipole for plus 4q? Generally, without seeing anything.
Minus 4q.
Minus 4q, yes.
Yeah.
So it means we require minus 4q, and for plus 3q, what do we require to make it a dipole?
Minus 3q.
Minus 3q. So see, minus 4q minus 3q. This is making a set of dipole, and this this is making a set of dipole. Now let's check the direction. So if this is minus, let us assume that here, see, this minus 7q is made up of, this minus 7q is made up of minus 4q and minus 3q. It will give you such a value only that you will be able to relate. From negative to the positive charge is our direction. So this will be P1. And from the negative to the positive is the direction, that is P2. So this is P1, this is P2, right? Now, class, the net resultant, this is a vector. So, of course, this will be P net will be pointing here. So, we should get the value of P1. Jesleen, can you tell me what should be the value of P1? Jesleen? Calculate the dipole moment P1, Jesleen. How should I write? Everything is given to us. 2p cos theta. No. See. This is the set of dipole. Minus 3q plus 3q separated by distance a. From what you have studied. 2p cos theta was when you know the theta. Right now, what if you don't know the angle? And also one more thing. How can you say 2p cos theta? Right now, this is different, this is different. P1 is different, P2 is different. So that won't be 2p cos theta this time. I wrote it as 2p cos theta, class, because see, one was p cos theta. When you resolve it, this side will have p cos theta, and this other side will also give you p cos theta on this side. Whereas these sides will give you p sin theta, and this will also give you p sin theta. So p sin theta will be cancelled. That's why I wrote. You just have to go the way you solve the vectors. But right now, for knowing the vectors, just tell me one thing. If this is the set of dipole that you have, what's the formula of dipole moment? Just tell me for this, Jesleen. What's the charge that I should write? What's the distance? How do we write? Q into L, exactly. So what is the charge here, Jesleen, for P1? Value of Q. No. I'm not asking for P2. I'm asking P1. Plus 3Q will be called a dipole when you have minus 3Q, exactly. And Jesleen, one more thing. When we discussed dipole moment in the class, that time I told you we take the magnitude of the charge. So even if minus 3 is given to us, we'll take 3Q only, because we have to consider the magnitude only. Dipole, it's like you have minus 3Q plus 3Q separated by A. So multiplied to A. So this will be 3Q into A. Ibrahim, can you tell me P2?
What, ma'am?
P2, can you tell me?
P2, 7Q into A.
No. How is your P2 formed? Second
Oh,
dipole.
okay, ma'am. P2, 4Q, so 4Q into A. Yeah,
Yes, very good. 4Q into A. Look,
yes,
now we are having, yes, 4QA. Correct, Jaslene. So this is 4QA. Now we have extracted our things that are helpful for us. That's it. If minus 7Q is there, this is not a dipole and this is not a dipole. But minus 7Q can be split into minus 4Q and minus 3Q. So that we extracted for our benefit. And then minus 4Q and plus Q is forming a dipole separated by, so 4QA. Minus 3Q plus 3Q is forming a dipole separated by, so we wrote it as 3QA. Now you have to get their resultant, right? So if you have 4QA and 3QA, I think answer is quite clear. It will be 5QA only because they are separated by 90 degree. So this will be 5QA. How you can use this whole thing? You can use the parallelogram law. But see class, this is cos 90, so it will be P1 square plus P2 square. When you write this 2, P1, P2 cos 90 degree, this term will be 0. And this will be under root 3QA whole square plus 4QA whole square. This is forming a Pythagorean triplet. So see, your QA will come out and you will be left with under root 3 square plus 4 square. So this is QA into root 25, which is equal to 5QA. This is the final answer. Got it, class?
yes, ma'am.
Okay, great. Write this. We'll discuss one more question based on this. Okay, so this says minus 100 millicoulomb charge is kept at this point, 3, comma minus 2, comma 5. Okay, and the plus 100 millicoulomb charge is kept at this point, 4, comma 3, comma 9. You have to find the dipole. See, for us, dipole is this only, minus q to plus q separated by distance a, and this will be the direction of the dipole from the negative to positive charge. Now, when we are talking about the dipole moment, we know the formula is q into L, q into the separation, or 2a that we write. So, charge is given as 100 millicoulomb, right? It is 100 into 10 to the power minus 3 coulomb. Multiply to now, see, the first point that was given. So, the first point, let's say R1 is 3i cap minus 2j cap plus 5k cap. We did a similar question, I think, in Coulomb's law also. Then R2 is there, 4i cap plus 3j cap plus 9k cap. Correct. So if we take R1, yeah, we did this, R1 minus R2. Ibrahim, you remember? I hope you remember we did it. So it will be R2 minus R1, where this is, because this is the final one, no? So this will be R2 minus R1. So 4i cap minus 3i cap gives you I cap. 3i cap minus 2, that becomes plus. So plus 5j cap. 9 minus 5 is plus 4k cap. So this is the position vector. Now you multiply the dipole. This is your L, because it is the separation between the charges. See, what did we do? Whenever you have the coordinates present, x, y, z, x comma y comma z, take R1, write it in terms of I cap, j cap, write it in Cartesian form. Even if one of it is 0, don't write that. Take that as, if suppose this was given, j cap was 0. So I would have directly written 3i cap plus 5i cap. Like this. Just write it in Cartesian form. You have the initial point, you have the final point. So subtract both of them. Initial and final are there. So final minus initial will be there. So R21, you can write this as R21 also, which is R2 minus R1. Why? Because these are position vectors. They are not distances that are scalars and we cannot solve it further. These are vector quantities. So R21 will be R2 minus R1. So we have the L. This will act as your L. This is the relative separation between both the charges. It's the relative separation. This is not the absolute separation. This is the relative separation between the charges. Now Q is there. Let me rewrite it. So we know Q is given as 100 millicoulombs. So this will be 100 millicoulomb, we'll write it. And this is I cap plus 5j cap plus 4k cap. So now what do? We take out the magnitude of it, because this is not how we can answer in Cartesian form whenever we have Cartesian form. So 100 into 10 to the power minus 3, this is the charge. And this will be under root 1 square plus 5 square plus 4 square, right? So this will be, this is 10 to the, see, this is 10 to the power 2. 2 minus 3 is minus 1. So 10 to the power minus 1. This is 1 plus 25 plus 60, right? So see, whenever you have to answer the questions in Cartesian form, calculate it in Cartesian form. And finally, whatever you write, see, this much will be coulomb meter will be the answer. Just write the relative separation. That will give you, this is actually your 2a that you write, means the separation between both the charges, positive Q and negative Q. Okay, these are the questions that are possible. Write it here. I'll give you a question similar to this one in the homework from your previous year NEET question. Okay. So just this time, write this test. Justine, you also share the homework for the NEET also, this today's class. The next week we'll discuss that. Please write it, all of you. Done. See class, the last question that has come from this topic in your NEET exam was this question in your NEET 2021's paper. This was the question. Otherwise, the questions that I told you in from dipole moment come in association with electric field. So in the next class, we'll do electric field due to dipole, and there are things different from what you study. So that part is important that we'll discuss properly, and lots of questions are there from that topic. Before starting with anything else, we'll discuss that first. So this came polar molecules. What are polar molecules? So having zero dipole moment, acquire a dipole moment only in the presence of electric field due to displacement of charges, acquire a dipole moment only when magnetic field is absent, have a permanent electric dipole. See class, polar molecules are basically, these are those molecules when we talk about polar, this is given in NCRT, so this question is important class. When we talk about the polar molecules, these have positive charges and negative charges. Okay, positive charges and negative charges are present. And these negative and positive, they never overlap. The positive and negative charges never overlap. Never overlap each other. So if they are not overlapping each other, see, if they overlap, what will happen? If the two charges are overlapping, they are coinciding, so they will just recombine. If two charges are present, they are coming in contact with each other and they are recombining. So that will, what will happen? Here the recombination will occur. Recombination will occur. Recombination will make the body back to neutral. That is, the net charge will be zero. Hence, the net dipole moment will be zero. But in polar molecules, they are never overlapping. Polar molecules are always arranged in this manner, like this. They always elongate, and one side becomes positive, one is negative. They are never coinciding. So as a result, what happens? There is a permanent dipole. This results in a permanent dipole moment, because the net charge is never zero. Like a good example that you have for a polar molecule is water. Remember water? These things are there in your NCRT. That's why I'm saying. Polar molecule is water. Basically, this is related to your chemistry part. So when you have water, the arrangement of water is this. This is, you know, how your chemistry's arrangement looks like. So when we talk about the dipole moment from in physics, see, when you have the same question in chemistry, the direction will be opposite. In physics, we have the net dipole moment like this. So here you will have the net dipole moment always present. So this is what is meant by polar molecules, and non-polar will always recombine. So this is related to your second chapter also. There we'll study this part. Potential also is involved in it. So the correct answer is D option. They have permanent electric dipole moment because the net charge is never zero. Q net will not be equal to zero. Class, is this question clear? Yes, Ibrahim, Jasleen?
Yes, ma'am.
All right. So, okay, Jasleen. Write down this one also. So this is the last question that has come in your NEET exam from dipole solely. Okay, class, just one last question from this. From the theoretical part, I just wanted to discuss. See, definition of a dipole moment. There was one question that has come from the definition of dipole. So it's an easy question. So I just want you both to answer me what is the correct answer to this according to you. Just tell me in the chat column, chat box, both of you. Yes, Ibrahim, right. See, answer is they are short distance forces. The definition of dipole is that two charges are separated, and this distance that we take, which we write it as 2a or L, this is very short. This distance is very small. That is how your dipole is constructed. Like when we talk about carbon dioxide, this is also a dipole. Okay, when you are talking about the carbon dioxide, O is there, C is there, you know, this is not the correct arrangement, how it is arrangement in arrangement, you know, from your chemistry. But if you talk about carbon and oxygen, and this carbon and oxygen, or you have simple HCl molecule, HCl is present, you have NH4 present, you have water present, like this. So they all have the short distance. So this question came a long time back, but these are the questions that are from the theory. One good question is there in your NEET previous year that I have given as a homework. So attempt that properly with the figure diagram, the way you attempt the subjective paper. I'll discuss that question in the next class, and then I'll start with the electric field part. Quickly write down this.